This is always exists, problem 5 from FBISD ULL practice 3. So a problem is basically you're given n integers and you want to rearrange those n integers such that the differences between adjacent elements is non-decreasing as you move from left to right in the array. So to construct a solution, we're going to take a look at sample input 1. So over here on the drawing board, I've sorted the numbers from sample input 1 to make it easier. So an intuitive way to construct the solution is if we go back to a problem and look at the constraint, we'll see that the last two elements in our constructed array is going to have the greatest difference. So if we want to, we want to ask the question, how can we create the greatest difference? And it's obvious that we want to take the largest element and then take the smallest element, as this will guarantee us we'll have the greatest difference. So then after that, we want to create the second largest difference. So then we take -4 and pair with 5. And then so on. And as you keep doing this, you'll realize a pattern. And it's that with these brackets, we want to keep taking, we want to alternate between taking the greatest element and the smallest element in a sorted array. And that's basically our solution. So let's code the solution up. Okay, so we want to start off by inputting the input. So I'm going to read in n. I'm also going to read in the array. Then we need to sort the array. So after we sort the array, we can go on to the main part of our algorithm. So I'm going to create another array that's going to serve as our answer. This is just going to be where we store what we've constructed so far. To do our construction, we're going to need a counter and 2 pointers, one for the start and one for the end. Actually, we need to initialize this counter to 0. So while the front pointer and the back pointer have not crossed each other, then we are going to determine whether the current element we need to put into answer is from the front or from the back. So since we alternate, we can basically use our counter I and its parity to determine whether we should put it at the front or at the back. So we're going to check the parity of I, and if it's even, then we're going to take the first element, the element from the front. And we're just going to also increment the pointers inside these statements just to make the code cleaner. And then otherwise, if the parity is odd, then we're going to take from the back. And finally, we'll increment our our counter. So after this while loop, our answer should be constructed, but an important thing to realize is we constructed it such that the adjacent differences are actually non-increasing. So we actually have to print out our constructed answer in reverse order in order to get the correct answer. So we're going to start looping from the back of the array. Oh, actually we can't use I because we already used it up here, so we're going to change this to J. It's going to be answer of I. And this should be the answer, the solution. Whoops. Okay, let's see what we did wrong. Seems like we just never printed anything out. So, okay, we went out of bounds on line 21. Not sure why this is going out of bounds. Oh, this needs to be J, not I. Up, and that should work, and this should be correct. Okay, that's correct. And that's the solution for problem 5 always exists.